to another edition of this program. I'm Adeka Solomon. Today we'll be looking at trigonometry of some special angles. But before we continue, don't forget to subscribe to my YouTube channel, Adeka Mathematical Solution, or follow me on Facebook and Instagram for more updates. Thank you for watching. Eh, As the example now, say example, if theta is acute and cos theta is equals to 3 over 5, find A sin theta, B tan theta, C cot theta, D cosec theta, and E sec theta. So the solution, recall that cos theta is the ratio of adjacent over hypotenuse. So now we consider a right angle triangle. We consider a right angled. We consider a right angle triangle A, B, and C. So we have this our A, capital A, this our capital A, this our B, and this our C. So since here is our A, here will be our small a. Since this is our B, this angle at B, here it will be our B. And here is the angle of C, which is the right angle triangle. When we talk about right angle triangle, which is angle 90 degree, and here it will be our C. But before we continue, there is what we call socatur. Socatur. The socatur, the S there, the S is sine, and which means sine is equals to the O here is opposite. All over the H here is for hypotenuse. And the C here is for cosine, which is cos. And is equals to A here is adjacent. And the H here is for the hypotenuse. And the T here is our tangent, which is tan. And our O is opposite. And our A here is adjacent. So using this socatur now, in our question now, we said our our cos theta is equals to 3 over 5. And we said our cos theta here, and here this angle here is theta. And cos theta is adjacent of our hypotenuse. So our adjacent here, this angle adjacent, and this one is opposite the angle theta, and this is the hypotenuse. So here our adjacent is what? Cos theta now is equals to A, which is our adjacent, and C, which is our hypotenuse. But in the question now, which is our A now is equals to 3, and our C is equals to 5. So, but the B is not given, which is the opposite. So for us to find the opposite, we to find the opposite, opposite, we will apply Pythagoras Pythagoras theorem, which Pythagoras theorem states that the hypotenuse, that is the hypotenuse square, is equals to the opposite square, that is the opposite square plus the adjacent square, which is the same thing as c square is equals to b square plus a square. So what we are looking for the opposite, that is AC, which is, and our C is what? 5 square is equals to our B now is what we are looking for, B square, plus our A is 3 square. So now, as applying for what we are looking for is B square, so we collect like terms and we have 5 square minus 3 square. It's minus because when you take a positive sign across equality sign, it change to negative, and when you take a negative across a an equality sign, it change to positive. So here, this positive 3 square change to negative 3 square, which is equals to b square, and our 5 square is equals to 25 minus 3 square is the same thing as 9, which is equals to b square. B square is equals to 25 minus 9, which is the same thing as 16. And our b, when we are finding the b, we are not looking for b square but b. Then we remove the square sign and put make this one the square root of 16. And the square root of 16, our b now is equals to 4. The square root of 16 is 4, which our b here, is now 4. So when you get this, you have already solved the problem, which our a part now, our a says sine theta, sine theta. So our sine theta now is equals to what? Using SOHCAHTOA, our sine is opposite of our hypotenuse. And our opposite is 4. And our hypotenuse now is 5. That is B all over C equals to 4 all over 5. And the B part now says tan theta. And our tan theta is what? Tan SOHCAHTOA say opposite over adjacent. That is tan theta is equals to our opposite now. Said opposite, which is B all over A, which is the same thing as 4 all over 3. And the C part now is what? We are looking for the cot theta. Cot theta, don't forget cot theta is equals to 1 all over tan theta. And 1 over tan theta, which is 1 over B all over A. And 1 over B over A is equals to A all over B. It's just the inverse of this. And when you take the inverse, it's now A all over B. And our A is what? Our A is 3. And our B is 4. So when you look at the value here, tan theta is 4 over 3. When you look at the inverse, it changed. The 3 goes up and the 4 comes down. It's the same thing here. And the D part is cosec sec theta. Cosec theta now is 1 all over of sine theta. And our, which is 1 equals to, our sine theta is SOHCAHTOA, sine theta is opposite of our hypotenuse, and our opposite is B or over C. So here I will take the inverse here as well, and it becomes C or over B. And C over B, our C is 5. This is equals to 5 or over, our C is 5 and our B is 4. Is 4. And we said cosec is 1 over sine theta. You know the sine theta here is 5 over 4. And the inverse of it is 5 over 4. 4 over 5 for the sine theta. The inverse of 4 over 5 is 5 over 4. Last but not the least, we have sec theta. Sec theta, which is 1 over cosec cos 1 over cos theta. And our cos theta from SOHCAHTOA is adjacent over hypotenuse, and our adjacent is A over C. And when you take the inverse as well, you have C over A, and our C is 5. Our C is 5, and our A is 3. So when you look at this, we said our cos theta in the question is given as 3 over 5. And the inverse of 3 over 5 is 5 over 3, which is the cosec theta. Remember again, when we talk about cot theta is the inverse of tan theta. We talk about cosec theta is the inverse of sine theta. And when we talk about sec theta, is the inverse of cos theta. Thank you for watching my video. Don't forget to subscribe to my YouTube channel, I think a mathematical solution. And follow me on Facebook and Instagram for more updates. Please subscribe for more updates.